Okay, today we're going to be talking about a really important issue regarding human memory, and in particular understanding more about how memory processes go awry, go wrong in the brain, and then more importantly, really exciting new research showing how to begin to reverse some of the early to mid-stage memory losses in dementia, and in particular with Alzheimer's. And so let's just jump right in. So first of all, of course, we just need to review why people develop serious memory problems, often in old age, 65 years and above. And so I think it's pretty well known by most of us that there are plaques, these sticky amyloid beta gooey substances that are circular in shape and grow between our nerve cells. And also, once there's been a proliferation of these amyloid beta plaques, then a secondary disease process starts to develop in our brains, and that is neurofibrillary tangles begin to form inside brain cells and destroy them. And so, of course, once that process begins, it continues, it's progressive, and it gets worse over time. So within 5 to 10 years, an individual can lose the capacity to not only remember, but to function independently, and they end up bedridden and very dependent upon others. All right, so the more recent research by Dr. Dale Bredesen at the University of California in Los Angeles indicates that years before problems show themselves, there's a lot of, let's say, negative kinds of impacts happening inside our brains. So what he has discovered, he and his team of researchers at UCLA have discovered, is there are these cells called dependence receptors, obviously receptor cells, and they're always monitoring the system to see if the proper molecule can be obtained by them. Once the disease process starts, there is a molecule that doesn't get received by the DR, and that sends a very negative, bad signal to what's happening in the brain, such that these dependence receptors start to move toward a disease state. And so let's just try to understand a few basic terms here. The dependence receptors, if they are to remain healthy, need to receive a ligand, which is an ion molecule, and the job of a ligand is to bind to others, often larger molecules. The non-disease process, the neutrophil, is proteins that really help to nourish and to develop other nerve cells. That is ideally what the ligand should be doing with a dependence receptor. But in a disease state, the dependence receptor does not get the neutrophil. And so, of course, these dependence receptors are protein cells, and they're always monitoring our nervous system for any kind of problematic molecules like the ligands, the metal ion cells. And so those are anti-growth factors, and that begins to cause the DR, the dependence receptor, to signal other cells to start killing themselves off. So cell death happens, and that's especially true when we're looking at tumors and cancer and negative kinds of disease states. So let's go further. So with these disease precursors, when the dependence receptors are not bound with the healthy neutrophils, they send messages to other cells to die off, as we've just said. One of the most problematic dependence receptors is called APP. So that's a precursor to plaque, right? So the official name of APP is amyloid precursor peptide. Peptides are building blocks of proteins, right? And so that is a dependence receptor. And of course, once that APP is produced, it can be cut in some not so healthy ways. So it can be cut in 3 ways and will produce 4 peptide molecules that start to signal the system to destroy brain synapses. So synapses are the ways that our nerve cells communicate, right? They need to have a chemical traveling from one to the next, and those synapses are crucial to thinking, memory, functioning. When the synapses are killed off, part of our brain is no longer functional. So this APP, not a good kind of dependence receptor, it can bind to dozens of other molecules that float around in our brains, and they can cause a number of health problems. Of course, dementia is one of the health problems, but there could be others related to diabetes and to disease states. So, for instance, when we age, with age, the balance of inputs that our system gets for good synaptic growth starts getting less common. It's more scarce to find good support. So APP, because it's trying to be efficient, trying to make the system function as best it can, even though it's losing certain key cells, it tries to keep only what it needs. And for instance, with dementia, that's why we see a common pattern. That is, some of the first cells to go would be the cells that contain the newest information. Newly learned information is let go. And also explains why it is that some of our longest held memories are the last to go. And so APP is, again, it's trying to be efficient, it's trying to maintain just what the system needs to function. All right, so with Bredeson's research, he basically says there are a number of risk factors for dementia. It's not just a singular kind of problem. And so you have to understand how APP, the amyloid precursor peptide, why that starts to form plaque and so on. And his therapy addresses enough of these 36 risk factors to actually see improvement among people who've already had some memory losses, and even, of course, prevention. So he's going to be putting a lot of emphasis, a very heavy emphasis on lifestyle factors, also suggesting certain supplements that people can take to protect their memories. And once the dementia has begun, in addition to what we've just mentioned, some drugs.